Hello everyone. In this video, we're going to be finding the inverse of a cubic function. Or at least we're gonna give it an attempt, right? We have f of x equals x cubed divided by 6 plus x squared plus 2x. We don't have a constant term. We could have had a constant term and that wouldn't really make a huge difference, but for some reason we don't. Anyways, this is a homemade problem, so I decided not to add a constant term. It wouldn't really matter too much. Now, can we find the inverse of any cubic function? That's a good question. So we're going to try to talk about that first, and then I'm going to show you how we can find the inverse of this particular function. I'm also going to show you a graph, actually two graphs at the end. Okay, are we ready? Let's get started. So first of all, can we find the inverse of any cubic function? For example, suppose f of x is equal to ax cubed plus bx squared plus cx plus d. And suppose we're exploring f inverse of x. F inverse does not mean the reciprocal, it just means the functional inverse. In other words, if you call f of x y, finding the inverse basically means solving for x. So the idea is, are we able to solve for x in terms of y? If we can do that, then we have an inverse. That's a good question, right? Well, solving for x involves solving a cubic equation, and it's quite complicated. Obviously, with the unknown coefficients, you kind of need to turn it into this and then solve this cubic equation, which involves a lot of steps, right? You kind of need to divide everything by a, like this, right? Let's do that first. And then I'll put that on the right-hand side, which is basically, well, it doesn't really matter too much at this point. Let's go ahead and keep it on the left now. And then we kind of need to use substitution, replace x with something so that we want to have a quadratic term, something with a square. Makes sense? And that can be done by replacing x with something like y or any other variable will do, minus b over 3a. That's the general approach. And the reason behind that is you basically take the coefficient of x squared, you divide it by the degree of the polynomial, which is 3, and then that gives you b over 3a, and then you negate it. You take the opposite. So if it's a plus b over a, you have to write this as minus b over 3a. Does that make sense? If it's a minus sign, then you make it a plus sign. Just think about the opposite. So once you do that, you're going to have an equation in y, but you will not have a y squared. You will have a y cubed, y, and a constant term, which you can then solve by using the following identity. If you think about this identity, we talked about this almost every time we have a cubic equation, right? This is where the cubic formula comes from, and whoever discovered it, we're not going to discuss it. You probably know the history. If not, look it up because that's pretty interesting. But here, if you replace y with m plus n, this equation basically have m plus n as a solution, right? So you can just kind of solve this because this basically turns into a system of quadratic, or a quadratic system of equations, in other words, right? And you can solve for m and n by taking some cube roots, put it together, you'll get y, and then using this formula, you'll get x. Good luck with that, because the problem is a cubic equation has 3 solutions, right? Right and wrong. Yes and no. Why? Depends. That's what we're going to talk about. That's why this equation is special. So in general, when you consider a cubic equation, let's say the graph of our cubic looks like this, which is pretty typical with 3 x-intercepts, right? That means those are real solutions. By the way, it doesn't have to have 3 real solutions. It can also have 1. Like imagine you move this graph up, obviously you're going to have at least 1 real solution, if the coefficients are real, of course, right? With the imaginary, it's a different story. But anyways, in this case, we seem to have 3 solutions. And guess what? This is not 1-to-1. So you can't really invert it because our function does not pass the horizontal line test. Does that make sense? For 3 different x values, we're going to have the same y value. Like call this x sub 1, x sub 2, and x sub 3, we have this y sub 1 value. When you invert it, it's not going to work because then you'll have 3x values, which is a violation. Okay? Make sense? So it's not going to work. Our function needs to be one-on-one. And I'll tell you why this problem from that perspective is very special. Let's get to work, find the inverse, and then we'll talk more about it. Okay? So here's our problem. I wanted to give you a little intro to finding the inverse, because finding inverse of a cubic function, and in other words, this cubic function has 3 inverses because you can split it up into 3 pieces, but finding them would be super duper complicated. We're not going to get into that. Maybe in another video. So first step, let me tell you, and this can be applied to any type of function. Replace f of x with y. And then your next step is going to be solving for x. All right? Replace f of x with y and then solve for x. Easy, right? Well, sort of, in special circumstances. Let's multiply everything by 6 because we want to get rid of the fractions. You don't want fractions. Do you like fractions? I don't. Sorry, fractions, no offense. And then multiply by 6, you get 12x, and this will be 6y. Now remember, always remember that our goal is to solve for x, okay? Just be focused. Now, this equation would be very hard to solve because y is another variable which is going to work as a parameter unless we have a special expression on the left, which we do. So here's what we're going to do. We're going to go ahead and move this stuff a little bit so I can show you. Oops. I was supposed to do with the equal sign. So like this maybe. Oops. Again. Trial number 3. Here we go. Okay. I'm going to go ahead and add 8 to both sides. And you know why? Because that makes the left-hand side a perfect cube. So you kind of need to know your cubes a little bit, right? This is x plus 2 cubed, which is awesome. This doesn't always happen. Of course, you can do a little bit of transformation, and that can happen. But again, that's a lot of work. Here we go. 6y plus 8. Now, what we can do to solve for x is cube root both sides, which we can do. And there's a unique solution in the real world, right? Remember, we're not working in the complex world. So here, now I can just subtract 2 from both sides, and there we go. We were able to solve for x, and that was our next step. Now, the step after this is writing what x means, because remember, f of x is y, but when you invert it, this is going to become f of negative log f inverse of y equals x. Because that's basically the idea. You have an x, you have a y, this is f inverse. You get the idea? So now I'm going to replace x with f inverse of y. And then now my inverse is in terms of y, and you don't want that, and don't ask why. You want it in terms of x, so I'm going to write this as f inverse of x equals the cube root of 6x plus 8 minus 2. So that's the inverse of our function because this function has a unique inverse. Let me tell you why. Do you know why? Okay, here we go. This function has a unique inverse because if you consider the original function and if you differentiate it, y, I'll show you. When you differentiate it, it's going to be 3x squared divided by 6 plus 2x plus 2. You see, the constant wouldn't matter because it would disappear anyways. But then you can kind of simplify this. And moreover, this is not super clear, is it? Unless you make a common denominator. And then you can write this as x squared plus 4x plus, oops, that's supposed to be a 2, hocus pocus. I turned it into a 4. Now it's going to turn into a 4, of course. Now we get that. And guess what? That is x plus 2 quantity squared over 2. Yay! F prime is always positive. At negative 2, something interesting happens, but don't worry. It's not a maximum or minimum because the sign does not change, right? So f prime is always positive except at negative 2. That means our function is always increasing, which means it is 1-to-1. So f of x is a 1-to-1 function, which means it's gonna continue to increase. Therefore, it's going to have a unique inverse. You don't believe that? Let me show you f of x and its inverse. Ta-da! Here we go. One of them is f of x. Can you tell which one? And the other one is inverse. As you can see, these two graphs are symmetrical with respect to the diagonal y equals x, because that's what inverting does. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.